This movie covers subtopic 7.2, climate change, causes and impacts, under the main topic of IB ESS Topic 7, climate change and energy production. The significant ideas in this subtopic include: climate change has been a normal feature of the Earth's history, but human activity has contributed to recent changes. There has been significant debate about the causes of climate change, and climate change causes widespread and significant impacts. Let's take a moment to define climate and weather. Climate describes how the atmosphere behaves over relative long periods of time in a regional area. It is related to the amounts of annual precipitation and amount and intensity of annual solar radiation. And climate impacts the net productivity of a biome. As I just mentioned, biomes reflect climate. Recall that biomes are large communities of plants and animals that occupy a distinct region defined by climate and dominant vegetation. Regions reflecting climate are locations that have similar annual averages of temperature, humidity, precipitation, sunshine, cloudiness, and winds. Weather describes the conditions in the atmosphere over a short period of time. For example, on May 27th, it was a cloudy day in Lima with a high temperature of 18 degrees. Weather is related to temperature, how hot or cold it will be on a given day, and precipitation, will it rain or snow, and whether it will be windy or sunny or cloudy. The weather impacts what you will wear and what you will do on a given day, whether you will bring a jacket or whether you will go camping or sailing on the weekend. Climate and weather are affected by oceanic and atmospheric circulatory systems. Oceans absorb and move heat in the conveyor belt currents. Movement of heat around the Earth in water and wind influences climate and weather. You can see the belt patterns in these two images. Atmospheric circulation includes the tricellular model of airflow. Recall that the Hadley cell, the Ferrel cell, and the polar cell serve to move heat and are responsible for the location of specific biomes. Remember that air rises over the equator, forming clouds and rainfall over the equator. Air sinks at 30 degrees north and south of the equator, resulting in dry conditions where the world's largest deserts occur. Air rises again at about 60 degrees north and south, resulting in rainfall. And air sinks over the poles, resulting in relatively low precipitation there. This is just a quick review of the tricellular model. Climate change has been a normal feature of Earth's history. In this graph, you can see fluctuations between hot and cold temperatures over a long period of time. These correlate with precession of Earth's wobble around its axis, toward or away from the sun. This cycle occurs about every 26,000 years. Temperature changes also correlate with the axial tilt, or the actual tilt of the axis, again, towards or away from the sun. This cycle of changing tilt occurs about every 41,000 years. About every 100,000 years, the orbit of the Earth around the sun changes, also contributing to changing temperatures. Finally, not pictured here, the solar cycle contributes to temperature changes, as there are times when the sunspots or solar flares are stronger than others, and the increase and decrease in sunspots also tends to be cyclical. So, climate change is a regular part of Earth's cycles. How do we know about climate change from before 1850, when reliable temperatures were first recorded? All of our estimates prior to 1850 are obtained through indirect or proxy data. As you can imagine, data obtained by proxy or indirect measurements has a higher degree of uncertainty than data obtained from direct measurements. Tree ring analysis is a method of indirect measurement of climate change. There are trees that live between 3,000 and 6,000 years. We can examine the rings within the trees to determine when there were poor and good years of growth. Then we interpret that data to indirectly estimate temperature and possible carbon dioxide levels. Wide rings are periods of high growth. versus narrow rings, which indicate low growth years. Here is a period of several years of drought, several narrow bands, one after another. Human records of crop harvests are another method of indirect measurement. Farmers record the amount of harvest, and by analyzing good and bad years, we can interpret the harvest data with respect to Earth's temperature. Ice cores drilled from Antarctica or Greenland provide data stretching back 400,000 years or more. And as ice compacts over time, tiny bubbles of the atmosphere, including greenhouse gases like carbon dioxide and methane, press inside the ice. These air pocket fossils provide samples of what the atmosphere was like when that layer of ice was formed, and historical temperatures can be estimated from that information. Tree line data along mountain slopes also provides indirect climate data. When the tree line moves up or down the slope, we can interpret these changes with respect to Earth's temperature. Indirect data then gets calibrated using data collected today for Earth's temperature and carbon dioxide levels. For example, using tree ring data, we measure the width of a tree ring this year, along with today's temperature and carbon dioxide levels. Then we calibrate the tree rings from older rings on older trees. So a tree ring with a certain width today can be used to determine that a ring with the same width 1,000 years ago grew at the same temperature and carbon dioxide levels. Then all the data from indirect sources is averaged to generate climate change models with a single line. Keep in mind that all these sources of data generate data with different units. So how can you actually average all of these numbers? Can you see that there is clearly uncertainty in this methodology? The Intergovernmental Panel for Climate Change published this graph in 2001, showing the average of all the indirect data, tree rings, crop harvests, ice cores, tree lines, used to generate the black line here. At the end, you can see the direct data from thermometers showing the recent rise in average earthly temperatures. The gray represents 2 standard deviations of the data. You can see that the uncertainty is quite large. In the past, the temperature could have been here or here or here, and at some data points the temperature could have been as high as today. This is what is known as the hockey stick graph. You can see why when you place a hockey stick right over the top of the image. Considering the previous slides, you can see that global climate change models are complex, and there is a degree of uncertainty regarding the accuracy of their predictions. Knowing that, you might understand now why there is significant debate about the cause of climate change. Whether you are looking at indirect data from thousands of years ago or more recent data like these 38 years of direct data, there does appear to be a correlation between temperature and carbon dioxide levels. What isn't obvious is whether changes in temperature affect carbon dioxide levels or whether changes in carbon dioxide levels affect temperature. Maybe both cases could be true. When you look at ancient ice core data, the rises in temperature precede the rises in carbon dioxide levels. However, when you look at more recent data, the rises in carbon dioxide levels precede rises in temperature. It is important to be aware of these uncertainties and acknowledge them in climate change discussions. Carbon dioxide concentrations are increasing, and this data is not in debate. There are well-documented data monitoring stations in Australia and Hawaii that are highly regarded and very reliable. Temperature changes fluctuate around rising carbon dioxide levels, and there appears to be a general increasing trend in temperatures. A proponent for anthropogenic climate change would argue that the rising temperature changes do correlate with increasing carbon dioxide levels. A climate skeptic would say that this graph is only over a short period of time. How are we sure that the temperature changes in this short time actually mean anything? How do we know that increasing carbon dioxide levels are related to human activities? Proponents of anthropogenic climate change argue that the most important part of the data is the rate in change as seen by the slope of the curve. This much change over a short period of time indicates change is due to human activity. You need to be able to evaluate contrasting viewpoints on the issue of climate change. While everyone agrees that there are elevated levels of carbon dioxide in the atmosphere, not everyone thinks that those levels are a direct impact of human activity, and some think that Earth is just too large to be affected by humans. However, scientists agree that human activities are causing a change in Earth's average temperature. There has been significant debate about the causes of climate change. There has been significant debate due to conflicting environmental value systems. Ecocentrics might argue for a plan to stop the use of fossil fuels in order to protect Earth. Anthropocentrists and technocentrists might argue that we should continue to drill, extract, and use fossil fuel because that's what's best for society and because we have the technology to ward off the impacts of climate change. Others are invested in the fossil fuel industry. These people wield political clout and money and alternative facts. Some follow political waves without thinking for themselves, or are swayed by weather patterns that don't fit the climate change trends, like colder summer days or an early start to winter. We need to listen to the scientific community that carefully studies climate change and its impacts. Scientists agree that climate change has been a normal feature of Earth's history, but human activity has contributed to recent changes. Let's define climate change. It is an increase in Earth's average temperature with more energy contained in air and water vapor. It is a change in global or regional climate patterns since the mid to late 20th century. It is an enhanced greenhouse effect due to the increase in greenhouse gases, particularly carbon dioxide in the atmosphere. Greenhouse gases play an important role in keeping Earth warm. The greenhouse effect. Recall, short wavelengths or solar energy arrives at the surface of Earth. Long wavelengths or infrared light is radiated back into the atmosphere. Greenhouse gases absorb the long wavelengths and re-radiate heat or infrared back to the Earth. The trapping of infrared wavelengths by greenhouse gases is the process that keeps Earth warm, with an average global temperature of 15 degrees. Remember, the greenhouse effect is a natural and necessary phenomenon for maintaining suitable temperatures for living systems. The enhanced greenhouse effect is the increase of greenhouse gases to the atmosphere due to human activities. Greenhouse gases are those atmospheric gases that absorb infrared radiation, causing global temperatures to be higher than they would otherwise be. The added greenhouse gases trap more long wavelengths, infrared, than is normal, causing an increase in average temperatures. Levels of greenhouse gases are increasing due to human activities. The added gases have caused an enhanced greenhouse effect. More re-radiated heat, more heat trapped, therefore warmer temperatures. Here is a list of 6 greenhouse gases. Memorize the first 5. All of these gases absorb long wavelengths, the infrared wavelengths radiated by Earth. They re-radiate the energy back to the Earth, contributing to the warming of Earth. Make sure you know the sources of these different greenhouse gases. Enhanced levels of CO2 in the atmosphere come from the human activities of fossil fuel combustion and deforestation. Enhanced methane levels come from anaerobic decomposition of organic matter in the rice paddy fields and the guts of cattle. Enhanced levels of dinitrogen oxide, nitrous oxide, come from the use of fertilizers in agriculture. Chlorofluorocarbons are released into the atmosphere from the use of refrigeration, air conditioning, aerosols, and solvents. Smog contributes to the tropospheric ozone. In topic 6, we talk about smog as an air pollutant. Keep in mind it is also a greenhouse gas. Keep the different roles, pollutant versus greenhouse gas, sorted in your mind. In recent years, there has been an increase in all of the greenhouse gases. Shown here are increases in carbon dioxide, methane, and nitrous oxide. Remember, it is an increase in the presence of these gases in the atmosphere that is driving the enhanced greenhouse effect. These increased greenhouse gases are driving climate change. Global warming potential is the relative measure of how much heat a known mass of a greenhouse gas traps over a number of years compared to the same mass of carbon dioxide. Not all gases have the same warming potential. Some cause more warming than others. This table is from your textbook. This table shows the increase in concentration of 5 greenhouse gases. Water is missing since the beginning of the Industrial Revolution. Additionally, the global warming potential is listed. Since we are comparing global warming potential to carbon dioxide, it has been assigned a global warming potential of 1. From this table, you can see that methane, nitrous oxide, CFCs, and ozone all have higher global warming potentials than carbon dioxide. However, because fossil fuel combustion releases so much carbon dioxide into the atmosphere, it contributes the most to the enhanced greenhouse effect out of all the greenhouse gases. Water vapor and methane are the next most important greenhouse gases in contributing to climate change. Stop the movie and study this slide. This graph shows a general increase in the concentration of CO2 over the past 50 years. Scientists do not debate the rise in carbon dioxide levels over time. The rise in carbon dioxide levels is well documented in particular monitoring stations in both Hawaii and Australia. The yearly fluctuations relates to the changing seasons in the Northern Hemisphere. The highs occur during the winter months when there is little photosynthesis occurring, while the lows occur during the summer months in the Northern Hemisphere when carbon dioxide is being removed from the atmosphere through photosynthesis. Again, as I mentioned previously, the increase in CO2 levels is the primary contributor to the enhanced greenhouse effect. In this image, you see countries by carbon dioxide emissions in thousands of tons per annum via the burning of fossil fuels. Blue the highest and green the lowest. If you study the image, you can see that the wealthier countries are those contributing to the most carbon dioxide emissions into the atmosphere. Human activities are increasing levels of greenhouse gases, such as carbon dioxide, methane, and water vapor into the atmosphere. In slide 27, I mentioned some human activities that release greenhouse gases into the atmosphere. Here they are again. Burning fossil fuels, deforestation, and cement all release huge amounts of carbon dioxide into the atmosphere. Cattle and rice farming release methane into the atmosphere. Fertilizers release nitrous oxide, and refrigeration, air conditioning, and aerosols all release chlorofluorocarbons into the atmosphere. Learn these human activities associated with climate change as well as which greenhouse gases they release into the atmosphere. Burning fossil fuels is the largest contributor to carbon dioxide levels in the atmosphere. Deforestation, removing trees that normally would remove CO2 from the atmosphere, results in more CO2 being in the atmosphere. Additionally, if the process of removing trees involves burning the forest, then more CO2 is being released into the atmosphere from the combustion of the wood. The manufacturing process of cement releases CO2 into the atmosphere. Cattle farming, with the anaerobic digestion of organic matter in the guts of cows, releases methane into the atmosphere. In rice farming, methane is released from flooded rice fields because bacteria in the waterlogged soil produce methane in large quantities. Soil microbes also release nitrous oxide into the atmosphere. Landfills also produce an anaerobic environment that results in microbes releasing methane into the atmosphere. Use of refrigerants, air conditioning, aerosols, foam packaging, etc. release CFCs into the atmosphere. The Montreal Protocol of 1987 has greatly reduced the additional release of CFCs into the atmosphere. However, as long as they exist in the troposphere, they are greenhouse gases contributing to the enhanced greenhouse effect and to climate change. Bacteria in the soil use the nitrogen from fertilizers, resulting in the release of nitrous oxide into the atmosphere. Don't forget that there is a baseline presence of greenhouse gases contributing to the essential greenhouse effect, of which water vapor is the highest contributor. Of the greenhouse gases coming from human activities, carbon dioxide is by far the highest representative. Human activities are increasing levels of greenhouse gases in the atmosphere, which leads to an increase in the mean global temperature, increased frequency and intensity of extreme weather events, the potential for long-term change in climate and weather patterns, and rise in sea level. There will be an increase in mean global temperatures. We have already talked about this correlating with rises in carbon dioxide levels. There will be an increase in the frequency and intensity of extreme weather events. This image depicts the potential for long-term change in climate and weather patterns. With changing climate and weather patterns, biomes shift. These areas that were previously covered in ice will become our food-growing areas, while these previously green areas will become desert. There will be rise in sea level due to the thermal expansion of water. The thermal expansion of water results in greater volume of water, as shown here. This extra volume has to go somewhere. This is a software-generated image of the impact of rising sea levels that will come upon U.S. cities. The thermal expansion of water will have a greater impact on rising sea levels than the melting ice sheets. So this brings us to this IB syllabus statement, which is essentially an extension of the last 4 slides. The potential impacts of climate change may vary from one location to another and may be perceived as either adverse or beneficial. These impacts may include changes in water availability, distribution of biomes and crop growing areas, loss of biodiversity and ecosystem services, coastal inundation, ocean acidification, and damage to human health. Water is likely to become more and more scarce in many locations. Water scarcity will be partially due to the melting glaciers that no longer can feed rivers. If the glaciers disappear altogether, many rivers will decline, become seasonal, or disappear along with the glacier that fed it. This would include many rivers in Asia and Western South America. Societies that depend on these rivers for drinking or growing crops will suffer. I showed this slide earlier when talking about the potential for long-term change in climate and weather patterns. These climate and weather changes will cause northward shift in biomes as depicted here. And this northward shift in biomes will cause the northward shift of the agricultural climate zone. The Intergovernmental Panel on Climate Change has predicted that crop yields will decline. This will result in people needing to adapt with new farming techniques. This diagram further illustrates the impact of shifting biomes. Here you can see the oak pine and oak hickory species in green, spreading and moving northward with climate change. Simultaneous to this, however, you can see the disappearance of the maple birch in red and the loblolly shortleaf pine in blue. You can imagine the additional impacts of the loss of tree species on other species as habitats and specific niches disappear. Furthermore, ecosystem services will also be lost. The ability of intact systems to hold soil, prevent flooding, purify water, and reduce erosion. Along with the northward shift of biomes comes the migration of pests and insects. This illustrates the northward migration of the deer tick, which isn't only a pest, but carries Lyme disease. Not only are vegetation, pests, and insects moving northward, but also larger animals. In this image, you see the northward movement of 20 different bird species between 1966 and 2005. As animals move northward, local diversity is changed. There is an additional loss of coral due to bleaching resulting from higher ocean temperatures. Coral are keystone species, with many species dependent on them for living. 25% of all marine life is dependent on coral. Melting Arctic ice threatens polar bears as they hunt for seals from the ice. This is an image comparing the actual loss of Arctic ice cap volume between the 1950s and 2000 and the projected by 2050. The loss of the ice cap will cause a loss of biodiversity. Increase in carbon dioxide in the atmosphere causes an increase in the uptake of carbon dioxide by the ocean. The increase of carbon dioxide in the ocean causes the ocean to become more acidic because the carbon dioxide reacts with water to form carbonic acid. This acidification makes it more difficult for mollusks and crustaceans to form their shells and for coral to make their homes. Ocean acidification results in fewer and smaller marine organisms that depend on carbonate to build their shells and homes, which is a further loss in biodiversity. Loss of shellfish will have huge economic impacts for those dependent on shellfish for a living. Loss of coral will have an impact on tourism. And finally, loss of coral also means less protection for coastal communities from storms because coral reefs can reduce the height of incoming waves. I already mentioned the climate change impact of thermal expansion of water and subsequent rising sea levels. This causes coastal flooding or coastal inundation. Coastal flooding will impact human health and the economy of society. The melting of the ice cap will also contribute to raising the world ocean levels, but thermal expansion will raise sea levels the most. Lack of available water can threaten human health. Extreme weather events can threaten human health. An increase in disease-carrying pests, like the deer tick I mentioned earlier, can threaten human health. You also need to be able to discuss the feedback mechanisms that would be associated with the change in mean global temperature. Negative and positive feedback mechanisms are associated with climate change and may involve long time lags. An example of a positive feedback loop with regard to climate change occurs in the water cycle. Remember, water as a vapor is a greenhouse gas. As temperature increases, more evaporation occurs. More water vapor causes more rise in temperature, which causes more evaporation, and so forth. Now, there is also a negative feedback mechanism occurring here, when increased evaporation causes the formation of more clouds. The clouds reflect light through their high albedo, which can cool the Earth, which results in a negative feedback. Another negative feedback loop occurs when increased evaporation causes more snowfall in the mountains, which results in more heat being reflected through albedo of the snow, which cools the Earth. A negative feedback. We do not know which of these loops is more important. Keep in mind that there are both negative and positive feedback loops associated with increased evaporation due to increases in temperature. We don't know if there will be more clouds reflecting light or more water vapor trapping heat. This adds to the confusion in the climate change debate because global climate change models are complex and there is a degree of uncertainty regarding the accuracy of their predictions. Another positive feedback loop is in the tundra. When tundra temperature increases, methane is released from thawing permafrost. More methane in the atmosphere means more greenhouse gases, more trapping of heat, thus increased temperature, and so on. Another example of positive feedback is when the polar ice melts. It results in more blue water, which reflects less light. Less light reflected, so temperature increases. Increasing temperature melts more ice, which means more blue water and even less light being reflected, and so on. When discussing feedback mechanisms that would be associated with the change in mean global temperature, always begin your discussion with an increase of global temperature. Then you can talk about the negative and positive feedback mechanisms. The negative feedback mechanisms include evaporations of water to produce cloud cover, which reflects light due to the albedo effect, reducing temperature. More snowfall over the poles, which also reflects light due to the albedo effect, lowering temperature. We didn't even discuss the possibility of increased photosynthesis due to increased amounts of phytoplankton. Then there are the positive feedback mechanisms. Evaporation of water leading to water vapor, which traps more heat, increasing temperature. Loss of polar ice caps, thus less reflected light due to albedo, thus increased temperature. methane release from tundra, which adds to the enhanced greenhouse effect. When will we reach a tipping point? Let's recap the contents of this movie. Climate change has been a normal feature of the Earth's history, but human activity has contributed to recent changes. There has been significant debate about the causes of climate change. Climate change causes widespread and significant impacts. Climate describes how the atmosphere behaves over relative long periods of time in a regional area. Weather describes the conditions in the atmosphere over a short period of time. Climate and weather are affected by oceanic and atmospheric circulatory systems. Human activities are increasing levels of greenhouse gases in the atmosphere, which leads to an increase in the mean global temperature, increased frequency and intensity of extreme weather events, the potential for long-term change in climate and weather patterns, and rise in sea level. The potential impacts of climate change may vary from one location to another and may be perceived as either adverse or beneficial. These impacts may include changes in water availability, distribution of biomes and crop growing areas, loss of biodiversity and ecosystem services, coastal inundation, ocean acidification, and damage to human health. Both negative and positive feedback mechanisms are associated with climate change and may in turn involve long time lags. Global climate change models are complex, and there is a degree of uncertainty regarding the accuracy of their predictions. There has been significant debate about the causes of climate change. There has been significant debate due to conflicting environmental value systems. This ends the movie for IB ESS Topic 7.2, Climate Change, Causes and Impacts, under the main Topic 7 of Climate Change and Energy Productions. The slides were created by me, Dr. Nina Markham. Images are a courtesy of Creative Commons unless otherwise indicated with a citation under the image. If all images on a slide are from the same source, the source is simply cited at the bottom of the slide. Additional insight was obtained from Mr. Dave Hoover's YouTube channel. Also a valuable resource for you. Another resource for you is your IB ESS textbook, whether in hardback form or online such as Cognity. Thank you for listening.